All right, so here we're going to talk about OSD Insight. So I talked about this a little when we first started this, right? But the ability to see how and when and why things are being built, where they're built, has value on multiple fronts. So and our challenges today is, how do we get that data, right? Well, today I can go in, if I know a machine was rebuilt, I can go look at some status messages and probably get some information about that machine. I could try to use the built-in reports, but who here thinks the ConfigMan built-in reports are the greatest thing ever? You're fired. So there are some good reports in the built-in reporting, but a lot of the reports leave a lot to be desired, and they haven't really been updated much over the last several years, which is quite shocking actually, because the company who wrote the software that manages the systems, that integrates with the software that was written for reporting, they're providing these reports and they're really not that great, many of them.
300 and some odd reports are terrible.
Yeah, out of the 400 default ones, yeah.
That's right.
Right, and the inability to see failure trends. Right? Can you say right now what is a trending failure across your organization? Because a lot of times the help desk will see this, right? They'll see a task sequence fail, but it'll never make its way back to you as the admin or the engineer who's managing this to know that those things are failing, right? They may just go manually install something and go, okay, it's good, just push it out the door, right? They may just re-image it and it works the second time, but you didn't get notified that, hey, it actually failed the first time, right? So it's very difficult today to find failure trends in your operating system deployment process. And then historical lookups. So can I go back 6 months ago and see any given machine, when was it built, where was it built, how was it built, did everything succeed, did it fail? Right, I can't really do that very well today in SCCM. So really we're talking about is overall lack of visibility into my operating systems platform that I spent so much time engineering, and I don't really have a good feel for how everything's working. So those are some big challenges. We have tried to overcome this challenge in what we're deeming the OSD Insights pack. Right, so all of our UEM as a service clients, which some of them are here today, we have this implemented in their environment. So we're tracking all of this process into a custom database. So we have some dashboards and some reports that we are continuing to ongoing develop. We have 25 or something reports right now, and a dashboard that we can send to the managers who oversee these, the engineers of this team. So they get a dashboard report every week that says, here's everything that was built last week, here's the successes, here's the failures, what was the most common failure if there were failures, right? What was my average speed of building a machine, right? So today, can you tell me how long it takes for your operating system deployment process to go? Right? Yeah, you may be able to ballpark it, but with this solution, you get raw data, right? This is how long it took. The key ability to identify failures and trends in failures. So one of our clients, actually, the day after we implemented this, right, we started seeing failure. So I contacted the manager and said, I'm seeing a lot of task sequence failures in your environment. It had to do with McAfee. Like, were you guys aware of this? No. Right, so the team that manages the infrastructure wasn't even aware of it. And when we put this in, within 2 days, we were able to identify, hey, there's a problem here. There is a McAfee problem here, and we need to solve it because you've got devices going out the door with no AV on them, right? And if the people aren't reporting this, you have no way of really knowing that that's happening unless you're just constantly in ConfigMan looking at deployment status messages, which everybody loves to sit around and do that all day, right? So we can correlate issues to machine types as well, right? So if we have failures, we can see, is that failure always happening on a very specific model, right? Then we know it's a problem with that model, maybe a driver problem or a firmware problem. And again, we talked about we could track build times. So that's important because if my average build process, let's say at my corporate office, is 45 minutes, 80 minutes, something like that, and all of a sudden I'm building a machine and it shoots to 2 hours. Maybe it completed successfully, right? Well, why is that? Well, it could be a boundary issue, right? Because now I'm sitting on my corporate network, but my boundary is configured to talk to some server that's across the LAN somewhere. And now I'm building a machine across a LAN link or something stupid like that, right? We can see those build times, we can see what distribution point that machine was built from, right? A lot of data that I'm going to show you here in the reports. And this process plugs into any task sequence. So whether it's in-place upgrades or wipe and load task sequences, we can track a lot of really good data around these processes. So without further ado, we're going to demo. So that's just kind of a snapshot of what we're going to see here. The data in this demo, it's in my lab, is actually a snapshot of real-world data with the sensitive stuff scrubbed. Yeah, everybody has Bob Smith. It's his admin account. Wow. That's enhanced. So let's try that. There we go. So remember I was talking about the McAfee issue, right? This is a snapshot of data of about 2 weeks after we implemented this into their environment. Right? We could see instantly McAfee endpoint security was failing to install. Right? So very quickly we were able to go back to our client and say, we've got a problem here, we need to figure this out. Right? We were able to determine what the issue was and remediate it so that that issue is now gone. Without this, we have to rely on people, techs who are out there doing it, to make sure that they're notifying us when this kind of stuff happens. So this is just a dashboard, right, that we can use to see like what is our average build time, right? What is our percentages of success and failures there? With these, I can drill down into successes if I want. My super speedy lab. Apparently not. There it goes. And this is just a small subset of data that I've pulled out of the database, the middleware database for this. I've got all sorts of additional detailed information that I could look at if I want. But for the summaries, I just want to see kind of a quick glance. What distribution point was that machine built off of? What task sequence was running to succeed or fail? Computer name, right? Where it was located from an Active Directory perspective. And of course, build date is always very useful. I can also get a count of how many task sequences, right? So this is important because, for instance, we have a client that still has Windows 7 and a Windows 8.1 task sequence that is required because of software in their environment. So those task sequences are still there and available. But their standard is Windows 10. So if we start seeing the numbers of Windows 8.1 and 7 tick up in this scenario, then we know people are using the wrong task sequence, right? We got to go address that. Today, you wouldn't really have any idea if that was happening. So that's one use of that. But just getting a glance to see how many people are building machines. Right? So we build all this awesome platform and this automated build process, and we make it super easy for techs to use. And then the double-edged sword there is that in many cases it becomes a crutch. Right? Do I troubleshoot, or do I just press this button and wipe it all out and let it start over? Right? There's a very good use case for that in some situations, right? But this process shouldn't be used as the first line of defense for troubleshooting, because you need to identify what problems are happening in your environment. So if you see machines being re-imaged at an alarming rate, right, that may be a conversation you have with your service desk and your desktop techs. Say, what's going on here? Why are we rebuilding these machines over and over and over? Are we not doing any troubleshooting, that sort of thing? So data that we can glean from that. And then I can do average build times per distribution point. Right, so I can see if, for instance, this is a remote site and it's 95 is my average build time. And then next month I run this report and I see that shot up to 240 minutes or 280 minutes. What is in that process that's causing that slowdown? Right, is it part of my task sequence? Is something stalled there? Is it a network issue? Is it a boundary issue? Kind of gives you some good insight into that. Let's go to let's see. Let's look at a failed deployments. Right. Oh, that's probably really hard to read that red on black text. I apologize. But as part of this, when a task sequence fails, right, as we all know, we can capture that failure in the task sequence, and we can do things based on the fact that that task sequence failed. Well, as part of this process, actually grabs the step from the log that failed in the task sequence. And we rewrite that into the record of this deployment so that we can see very quickly what failed on that device. So there's a lot of good useful information from an administrative standpoint, right? For us as admins, you know, I can't tell you how often I have spent going back and forth with end users or desktop techs trying to get all the information I need to troubleshoot this device, right? Generally, it's this task sequence failed, right? And it has an exit code of blah, 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 and they give you that nice exit code that's on screen that doesn't really tell you anything about what actually failed. So you're going back and forth, well, I need to get the logs, right? Can you send me the logs? Can you open a command prompt and, you know, blah, blah, blah. You spend a lot of time going back and forth with desktop techs to try to figure out what is actually happening, where this is going to capture all the logs in the failure process to a network share, and it's going to write what the actual step in the task sequence that failed is so that you can see it right there at a glance. So if somebody calls and says, hey, my task sequence failed, you can just go right here and go, what's the machine name? Okay, I see the task sequence, I see why it failed. Now let me go dig through the logs that I've captured to see how to remediate. Yes, sir?
The common scenario that we've had to use this for also is people just plain being inquiry and saying, you say, I've got this test sequence for you to test this driver you requested, and they say it failed, and you look and they ran the production test sequence.
Yes. That's a good point. Yeah. So interfacing with, you know, people who are testing and things like that.
Information saves you a lot of time and emails back and forth.
Yeah. No, let's go to, what do we got here? So this was on our dashboard, but here I can also get a report of different task sequences that were executed. And I could drill down into that and look at all of the records, right? See why it failed, what task sequence, when it ran, what's location, which distribution point, tracking the elapsed time. We actually also do a speed test, which is how we get those average, oh no, that's not that, it's a different set, but we're doing a speed test as part of this, and we're capturing that information as well, so that we can trend speed tests to the distribution point over time. So if we see it's fairly level most of the time, we're good, or maybe the third week of every month we see it spike way up, right? What's going on where during that time period, the LAN traffic seems to be flooded.
So right now, this is just for the deployment itself. Is there like a future state for deployments of like applications and packages?
So the short answer is yes. We have designs on taking the same sort of functionality that we're doing for OS deployment and seeing how we can glean that for application software updates, things like that. We're not there yet, but that is definitely on our roadmap to do something very similar to this around applications and other features of SCCM, for sure. What else we got in here? Oh, yeah, so I can do deployments by date range, right? So if you ever want to go back and look how many machines were built and deployed last month, right? I can go run those date range reports. Now this data is a couple of months old, so I got to go back to May. And I can view that report. So I can see all the machines that were built, whether there's a success, failure, what task sequence, and what distribution point they were built off of. So as you can see, when we first implemented, this is where we started seeing all these McAfee failing to install, which prompted us to take action. Deployments by date range. That was the snapshot overview. You already seen that. Average build time. Yeah, so that's build time. We have a new report that we're actually sending to our clients on a weekly basis, but unfortunately this data is old, so there is no weekly report because it's my lab data and it's not being kept up to date. But part of this, we're actually tracking the average in-place upgrade time as well. So we plug this into our Windows 10 pre-caching task sequence and our Windows 10 in-place upgrade task sequence. So we can track the time, success, failures of those as well as part of this process. And the ability to get an average in-place upgrade time is massive, because then you have better ammo to go at your users to say, this is going to take 3 hours, or this is going to take about an hour, right? You've got data in here that you can validate towards that process. And again, trending failures, right? We can see that McAfee endpoint security 10.6.1, we had 20 failures over the course of whatever the snapshot of this data was. So there's a problem there, right? And then again, our average Pixie build time per distribution point. So a lot of really good insight data in here. This is still being developed. So although we are using it actively and we're gaining value from it and we're supplying data to our clients from it, we are still actively developing this, right? Adding more things in. Just recently we added in the ability to grab Tpm information, right? So now we can easily report in this same location when a machine was built. I can look at, was it built in UEFI or was it legacy? Does it have TPM 1.2 or 2.0? Is the TPM on, owned, active? All of that information is now also stored in this database that I can look up for any machine in my environment. So some of that hasn't made it into my lab because the newer features we just implemented all of our clients, I did not port into my lab for today's demo, unfortunately. We'll just take a very quick look at the database so I can kind of show you everything that's being collected. UEM. Okay, so this is where those reports were pulling from. So we can see all the different stuff we're capturing, right? Start time, end time, that's how we get to the elapsed time. What model it was. So as you can see here, one of the fixes that we had to add in that it was actually a bug in the script that converts or looks at the computer system product class of WMI on Lenovo, since they want to be unique and not store their friendly names where everybody else does. So that's actually addressed now in production, but not in this database. Manufacturer, target OU, and actual OU. Now I pulled those out because I didn't want to have you guys see actual real world OU structures for one of our clients. But I know on many occasions I've been in a scenario where somebody calls and says, I built this machine, but something's acting funny or it's not configured right. Right? I can go and look in that record and I can see what did my task sequence tell me that machine should be going to, what OU, and then what OU is it actually sitting in. Right? So that tells me that the computer already existed, maybe in the wrong OU, and maybe I need to implement a process into my task sequence to make sure it moves objects from its existing OU to whatever your machine object OU variable in your task sequence says, which is fairly easy to implement. But we can also track, is that actually working, right? If it's failing, why is it failing? We can see this is what the task sequence said it should be, this is what it actually is. If those don't match, then we need to go take action and figure out why. Location is actually something that's tied into a product that we use. So it's a model developed product called DDI. It's the Dynamic Deployment Interface. I'm not going to do too much deep diving on it today, but it's basically a front end to your Pixie task sequences that allows you to do a very, very large set of things to make your task sequence more dynamic. One of those is a location selector. So if I want to do things based on where my device is, I can use the DDI to set those locations. I'm capturing that information as part of this. So if you don't use DDI, this will just show up as a null entry. Capturing how much memory is in the device, the disk size of the device, and the disk type. So I can start to, and we haven't done this yet, but eventually we want to get to the point where I want to run reports where I can tell a time difference, and I can provide that to my business to say, these machines that have SSDs, they build in 40 minutes. Right? These machines that have 5,400 RPM hard drives take 2.5 hours. Right? Is there a trade-off on upgrading that hard drive to an SSD to make the user more productive? May or may not be useful to you, but it's something that we wanted to have there in case that scenario came up. We can track that. IP address is key because it's generally one of the first things we ask the text, right? What's the IP address? We want to make sure that if it's not able to build successfully, right? Is there anything in the subnet that they're on that's maybe having problems, right? So we can get that information. Installed apps. So you can't see it because I'm not going to expand it because it'll fling it right way off the window here. But we're also tracking applications that were installed into the add remove programs or programs and features, in the registry per build, right? So I can go back and see everything that was installed that day. It's going to disregard anything that's in your core image because it's not going to have an install date of today. So that's what we're keying off of. So if I have an install date of today, it's going to grab all of that information so I can see what applications were installed on that device during that deployment. And then of course I'm pulling what distribution point I'm running from, so that's always good for us too, right? If we don't know, somebody just says a build failed, we can go see where this machine was at, what distribution point it was using, and see if there's a problem on that DP, for example. Speed test. We're tracking this information, so eventually we'll be able to graph, average speeds of our communication from our client to the distribution point. So if we see spikes in that, we can try to figure out why. Tracking what kind of start type. I think all of these, or most of these, are going to be Pixie. Oh, we got some client initiated in here. So did I initiate this task sequence from a Pixie boot, or did I do a Software Center or one VIN front end to Software Center task sequence deployment, right? So was it client initiated or was it Pixie initiated? And this will also track if you're doing USB, right? If you take the same task sequence, you put it on a USB stick, you ship that out, the information that goes in here is that it was built from USB, right? So give you an idea of how many machines are being Pixie booted versus upgraded through a task sequence. If you're using user affinity as part of any sort of front end structure that basically sets, there's a variable that you can set that if you're using any front end tool like DDI, for example, that we use, that allows us to do user affinity, it sets a variable that SCCM knows about. It's a standard variable that'll define that affinity as part of the deployment process. If that's entered into the process, then that user affinity will also show up here. Tracking what chassis type, the serial number, MAC address, AD site, boot mode, right? So I can report back to our clients, hey, your techs are building all these Windows 10 machines, but they're all in a legacy configuration, right? So all of those cool security features you implemented via GPO in Windows 10 are not going to apply to these machines. So having the ability to see that that is happening and being able to go to address it and say, hey, make sure that we're flipping those BIOSes to UEFI before you Pixie boot these machines and build it with Windows 10. And the start date is something we're just using the key off of, and then of course we enabled the TPM version, whether it's enabled, owned, or activated. So a lot of really useful information in here that we can carve up many ways to provide value, not only for us as the people who are troubleshooting and trying to remediate issues, right, but being able to provide a dashboard now to our clients to say, here's all of the activity around operating system deployment that's happened in the last 7 days or the last 30 days. And we give them the ability to run reports. If they want to go look a machine up and see when it was rebuilt, they can do that now. So very, very useful here. Full disclosure, this whole thing came about by me reading a blog from somebody else who was doing something sort of similar, but they weren't using any sort of database. They were just using log files that they could go look at and capture some information about that process. That sparked the idea of, well, if I'm going to do that, why don't I store that data so I can create reports? And what started as just a handful of data about what we were looking at in the blog is now turned into 3 or 4 revisions later of all of this data that we find now useful for our troubleshooting or for our clients. So still being developed. I wouldn't consider this the end-all final release. I'm sure we'll find other things that we want to capture as part of this process as we go along. But generally speaking, it's a pretty easy upgrade process to get this upgraded. So if it's something that you're interested in, again, this is something that we implement if you are a partner of ours in a UEM as a service capacity. This is something that we just implement standard so that everybody has it. So you guys have it, Rick, you guys have it. Yeah. Yeah, you actually should be getting a weekly report out of it. So, okay, good. So just let us know if you're interested to hear more about it. Yes, sir.
So it seems like it's an off-premise solution. Is there a way to do that for us, we're a financial, institution? I can see a problem sending all that data off-site to a third party.
This is all self-contained in your network.
So it is? Okay.
Yes. Yeah, so our general recommendation, although it's not a requirement, would be to create the database for this on your SCCM server. It's a fairly small database, so that it is all self-contained in your environment, in your data center. If the database needs to live somewhere else, you could do that as well. It'll still write to it no matter where it lives. But the way we've been implementing is just a complement to the SCCM database on that server, and that's where we're storing the data. Yeah. Yeah, this wouldn't fly in many organizations if this was like a cloud-based solution. We're taking all this data and storing it in somebody else's data center effectively. No, so this is completely on-prem. Any other questions? No. All right.